Let us now try to solve this problem. So solution for this problem. Now let's see what are the given here. What values are given. So we have 1 gigawatt. So 1 gigawatt for coal. So this is for coal here. So 1 gigawatt is the, what is that? That is the rated power. Okay, that is the maximum power that the coal power plant can produce. So that's 1 gigawatt of electricity. And the capacity factor was also given for coal. So that is 70% or 0.7. And what we are going to find out, or what is asked, is the net annual savings. So net annual savings in CO2 emissions. So net annual, so yearly, CO2 emission savings. This is based on the use of wind turbines instead of coal power plants. So when we say net annual CO2 savings, we are referring to the quantity, the amount. So there should be, we're looking at kilograms of CO2. So how much kilograms of CO2 is saved if we use wind turbines? All right, so how do we get this one, the amount of CO2? So based from here, so what we're looking at is actually this amount of CO2. Amount of CO2 can be in terms of kilograms, okay? In terms of kilograms, can be calculated by knowing the actual total energy produced, okay? Actual total energy produced, all right, times the emission, CO2 emissions, CO2 emission per unit electrical energy, per unit electrical energy. So that means this one should be in terms of kilograms CO2 per megawatt hour. All right. So when we are looking at coal, for example, so what we are going to, if we are looking for coal, so this must be based on coal CO2 emission. So where do we get this one? Where do we get this part here? So I already shown you before in this table here. You can see to the upper right hand corner, you can see that there's one for coal. So coal has CO2 emission per unit electrical energy of 955 kilograms CO2 per megawatt hour. The same way we can look for wind. So you can see from here there's wind, and wind has the a range of 7 to 9. So if it's a range, you usually get the average. In this case is 8 kilogram CO2 per megawatt hour. So now we have the values of these things here that we can use to use in this term. Now the question is, how do we get this term, the total actual energy produced for coal and also for wind? So we need to get that value. So let's start with coal. So let's start with coal here. So this is coal. So as we have remembered with regards to the definition of capacity factor, so capacity factor is equal to the actual total energy over the rated energy, or the capacity. So I will just put rated here, right? So in this case, for coal, we can now get the total actual energy because CF is already given and E rated is not given, but we can solve for it. The reason is we can say that power, or we can get the energy, E rated energy is equal to what? Power rated times time. using this formula, because we know that power is energy over time, so we can just um, rearrange it into power times time. So in this case, we are given with power, the rated power, which is this one. And how much is the time? This is an annual one, so this is year, based on year. But we want to use hours. So how many hours in 1 year? So you have to know that one. So in this case, and CF, capacity factor, is also given. So now we can actually possibly solve for actual total energy. But first, let's solve for the rated energy. So A rated is power, which is in this case is 1 gigawatt, times time, 1 year. And then we change this year into hours. How many hours in 1 year? 8,760 hours per year. So cancel, cancel. So you get 8,760 gigawatt hours. So now we get the A-rated rated energy. But since our unit in the emission is in megawatt hour, you can see on the upper right hand. So we need to convert this one. We need to convert into megawatt hour. How do we do that? Multiply by 1,000 megawatt hour over 1 gigawatt hour. Just the conversion factor. And so we can get the final megawatt hour now. So 8, it will be like this, times 1,000 megawatt hour. So 8,760,000 megawatt hour. Or what we can do with that is, okay. So now we can continue to get this part here, the actual total energy. So let's try to move it here. All right. So again, CF equal to actual total energy over E rated. Now everything is here already for coal. So the actual total energy is equal to CF times E rated. So now CF is 70%, which is 0.7, times the E rated is already here, right? So that means that 8.76 times 10 to 1, 2, 3, 4, 5, 6, 6, right? Megawatt hour. So the E rated is equal to 6.13 times 10 to the 6 megawatt hour per year. So that is the E actual total energy for coal, right? So this is coal. So once we have that E actual total energy, then we can calculate now for the amount of CO2 emissions. So it means that with that, so the amount of CO2 emission is equal to this number here. So 6.13 times 10 to the 6 megawatt hour per year times the emission of coal at the top. You can see 955. 955 times 955, sorry, 955, I'll delete this one, kilograms per megawatt hour per year. So in this case, per year. Cancel this one, cancel. So what happens is only kilogram is left. So for coal, the amount for coal is 5.856 times 10 to the 9 kilograms. So this is the amount of coal CO2 emissions. CO2 emission coal. Alright, so that is for the coal. So this is A, is coal. B is for wind. Okay, so the same way we can now calculate the amount of CO2 emission for wind, because we already have the same, because the problem says it has to be the same power generation or energy generation. So basically, this part here, the 6.3 times 10 to the 6 megawatt hour per year, should be the same for wind. So for the amount of CO2 emission in wind should be the same amount for the actual energy, 6.13 times 10 to the 6 megawatt hour per year, times now the wind emission per unit electrical energy is 8 kilogram CO2 per megawatt hour, so per year. Cancel, so it equal to how much is that? 4.904 times 10 to the 7 kilograms. So this is now the amount of emission in terms of kilogram for wind. So what is the net savings now? So letter C is the net savings. We don't have the space now, but I will just put it here. So the net savings is basically this value from coal minus this value from wind, because that's the total amount of CO2 emission. So we can just equal, so this is the net CO2 emissions, so I will just put net there. So basically it's 5.856 times 10 to the 9 minus 4.904 times 10 to the 7 is equal to, the final answer should be 5.8 times 10 to the 9 kilograms. 9 kilograms. So basically, unfortunately, we don't have the space here, but this is the final answer. All right, so the final answer, I will put it here on top. The net amount is net CO2 savings is equal to 5.8 times 10 to the 9 kilogram CO2. So this is now the final answer for this problem. It's a little bit messy, but I hope you still can follow the process. And so your final answer should be in this part here on top. All right.